LangChain is incredible for building AI applications, but have you ever wondered how does all the pieces fit together? What happens when you chain prompts, tools, and agents? Where does the data flow? Or how you can pinpoint issues when things goes wrong? Well, today we are going to unlock all the secrets using LangSmith, the ultimate observability tool for LangChain. I am Maat Fataya and I am just as curious as you are, and that's why I'm excited to share LangSmith with you, the tool shining a light on the inner working of your LangChain projects. On today's video, I'm going to show you how you can use LangSmith to monitor, debug, and optimize your large language model application. We will cover everything from installation to advanced technique, so that you become a LangSmith pro. So, let's get started. Hey everyone, and welcome back to my channel. Today we will dive into the world of LangSmith. If you are building your AI applications using LangChain, then you are in for a treat, because LangSmith is your secret weapon for gaining complete control and visibility over your LLM workflow. LangSmith is not just a tool, it's your ultimate toolkit for your LLM observability and debugging. It's your go-to for troubleshooting issues, understanding chains, and optimizing models. We will dive into these unique selling points and more in this tutorial. See, this tutorial is not just about theory. We are going to build real-world application and code demonstration. We will start by installing LangSmith, setting it up, and then we will dive into some practical example. We will build a simple LLM application and see how LangSmith allows us to track what's happening behind the scene. But we will not stop there. We are going to explore advanced features like Context Manager, tags, and group, plus we will dive into LangSmith Client for some programmatic control. Stick around for advanced tips to level up your LLM game. And first, let us get started by getting familiar with the LangSmith interface. Alright everyone, let us get started. The first step, as usual with any new tool, is to sign up. And you can sign up to LangSmith using Gmail account, GitHub, your personal account. So after creating your own account and sign in, it will take you to the home page, where you will have access to projects, dataset and testing, annotation queues, and prompt. The first thing that I would like to show you, it's very new and exciting, and it's called LangChain Hub, which is right here in the bottom left. When you click on it, here in LangChain Hub, you can explore, share, and even version control prompts for LangChain and other LLMs, okay? It's a great place to find inspiration and share your own prompt. Let us take a quick look at one of the prompts. Let's say this one, prompt maker. When you go inside here you'll find the definition of this prompt, and you can even try it out. When you click here on the top right, try it out. Of course, you have to enter the variables, and then you can click start, but also you need to have an API key. So it will ask you here for OpenAI API key, and then you will be able to see the result in real time. It's a fantastic way to experiment with different prompts and model. Now let's go back to the home page and take a look at projects. In the home page here you have access to your existing projects, where you can create a new project from here, but we are going to do it from Jupyter Notebook. And in order to do that, we have to create our own LangSmith API key. So if you go to the setting on the bottom left corner here, you will have the option to create an API key. Enter the description and create API key, and then you will have your own API key. Now since we are going to create the project from the Jupyter Notebook, if we go back now to the home page and we go to the documentation, we have to install LangSmith using the following command and store the API key in your local machine. And to set up the environment variable, we need the following three keys, okay? LangChain tracing version 2, LangChain API key, and OpenAI API key, alright? So now let's go to Jupyter Notebook and start writing the code for our first application. Alright everyone, let us get started by building a simple LLM application that answers questions. On the surface, it might not look like much, but with LangSmith, we will uncover hidden depths and reveal the inner working of this simple application using LangChain Tracer. So the first tool that we are going to explore is LangChain Tracer. Now let us jump into Jupyter Notebook and start building our application. For this project, we need the following libraries. We need LangSmith, LangChain, OpenAI, and Python-.env. I have already installed these libraries. The next step here, we have to load the environment variable. And I have already copied all the required API keys. The OpenAI API key, LangChain tracing v2 with the default value set to true, and the LangChain API key as well. And I stored them in .env file in the same location as this Jupyter Notebook. Alright? And I confirmed that the OpenAI API key loaded successfully. Okay, now let's start building the simple application. We are going to build a simple chat model. We are not going to use any chain, and we are going to use the predict method of the LLM. Alright, so we'll say from LangChain.chat_models import chat open AI. Now we'll create our LLM object. It's equal to chat OpenAI, and now we will use the predict method LLM.predict, and then we are going to ask the LLM how is the weather in UAE. Let's run the code cell. It's gonna take a little bit of time, and we get the answer. The weather in the UAE is typically hot and sunny throughout the year. This is the standard response from OpenAI, so nothing really spectacular. But if we go to LangSmith now, we will find a new project with the name default. Okay, this is because we set the enable tracing to true in the .env file, but we did not set an environment variable for the project name. So if we click now on the project name here default, then we can see our code here with our class chat OpenAI the input. Here we can see the start time, the latency, and the use token. Alright, and if we click here on chat OpenAI, we can see here the input, how is the weather in UAE, and the output, this is the answer, and we see the start time, end time, and so on. So this works out of the box, and just by setting the tracing to true and setting the API key, we can monitor our application. So we can see what classes were called, what the input was, the time, and so on. So LangSmith gives you monitoring without any code changes, but we cannot only enable or disable tracing with environment variable. You also have got more control with LangSmith. We are going to see how next. Now we will use LangChain Tracer. So here, LangChain Tracer, okay? But first, why we want to use the LangChain Tracer? LangChain Tracer will give us more control than just using a single environment variable. So let's see how. So here we'll say from LangChain.callbacks import LangChain Tracer. You can think of LangChain Tracer as a detective that records every detail of your LLM's work, okay? So next we have to create the tracer object. We'll call it tracer is equal to LangChain Tracer, and it's expecting a project name. So as you saw before, the project name was default because we did not specify it. So here we'll say project underscore name is equal to let's say tracer, no, LangChain Tracer project, okay? Then we will ask the LLM.predict how many people live in UAE, okay? And we pass this tracer as a callback. So we'll say here callbacks is equal to tracer, okay? So this basically tells the LangSmith to pay attention and start taking notes on what the LLM is doing. Okay, let's run the code and we get our answer, 9.9 million people as of 2021. Now let's switch back to LangSmith UI, and here we can see we have a new project called LangChain Tracer project. And if we click on Chat OpenAI, we can see our input, how many live in UAE, and the output, and the status, and total token used. Okay. In the next part, we are going to see how we are going to use the Context Manager. Alright, now we are going to talk about the Context Manager. So instead of using the environment variable to enable tracing, we can use a simple handy tool called Context Manager. This is like creating a special zone within your code where LangSmith track everything that happened. It is perfect for grouping multiple LLM calls, making it easier to analyze and compare their result. This can be especially helpful when you are experimenting with different prompts and chain configuration and want to see their impacts on your LLM. Now, let us jump into Jupyter Notebook and see how we can implement the Context Manager. To use the Context Manager, we have to import a class called tracing_v2_enable from the callback again. So we'll say here from LangChain.callbacks import tracing v2 enable. So this is another way to use LangSmith tracing without setting up the environment variable. Okay, so this will be like creating a temporary workspace for your code, and anything that happens inside it, it will get automatically tracked by LangSmith. Okay, next we will say with tracing_v2 enabled for project underscore name. I'm going to use the same project that we created before, LangChain tracer project. Okay, and then here I will say LLM.predict how many people live in, let's say, France. Okay, let's run our code. It is done. Now let's switch back to LangSmith interface. And as you can see, it's already updated in LangSmith. We see another call to LLM again here. So if we click on this one, the first one, Chat OpenAI, we can see our question here, how many people live in France. And this is the output from the LLM, along with how many token and the start time and the end time. So Context Manager allows us to group multiple LLM calls together, which allow us to analyze and compare the result. And if we go back here on the right side, we have the filter menu. This filter menu allows us to filter run by the type, success, the latency, the cancelled, and metadata, and even by tags, which we will talk about next. In LangSmith, tags allow us to run with additional information, makes it easier to search and filter through our data. For example, we could tags run based on the model used, type of task, or even specific parameter. This makes it easier to compare performance across different configurations and quickly find the information we need. Let's now jump to Jupyter Notebook and see how we can implement tags. To demonstrate how to use tags, I'm going to create a simple chain application now. And to create the simple application chain, we need LLM chain, Chat OpenAI, and prompt template. So we'll say from LangChain.chains import LLM chain, and from LangChain.chat_models import Chat OpenAI. Okay, and from LangChain.prompts import prompt template. Okay, now to set tags, we have multiple options. We can either set it in the constructor of the large language model, or we can set it also on the chain itself. Let's see how. Here I'm creating an LLM object is equal to Chat OpenAI. For temperature, I'm going to set it to 0, and for tags it's equal to, here we are setting the tags in the LLM constructor. Let's say LLM dash tag. Okay, next we'll create our prompt is equal to prompt template dot from underscore template, and let's say here it doesn't matter, I'm going to just put an input. Okay, next I'm going to create the chain, so we'll say here chain is equal to LLM chain, LLM is equal to LLM, and the prompt is equal to prompt, And here also we can set the tags as well. So we have two options, as I said. Let's say here chain dash tag and another dash tag. Okay, now let's run our chain. So we'll say chain hello world. Okay, we can add tags here as well. Is equal to shared dash tags. Let's run the code cell and we get the response. Now let's switch back to LangSmith interface and see what happened. And here in LangSmith, we can see we have two run counts here. Since we did not specify the project name, it will automatically save it or run it under the default project. So if we go to the default project, we can see now we have our chain here. If we click on it, and here as well, we can see we have a call run to LLM, to chat OpenAI. We can see also the status, the start time, end time, and latency as well. Okay, and what is important here is the tags. We can see here we have the shared tag, chain, and another tag, and also here as well. Let's close this one. Here we can see the tags that we defined. We can filter now based on the tags, shared tags, or for example, chain tag, and so on. So this helps us to filter call for specific runs. All right. While working with LangSmith, you could think of groups as folders within your LangSmith experiment. You could organize run based on different criteria, like trying out a new prompt, testing different model, or track changes over time. This makes it simple to compare results side by side, figure out what worked best, and make smarter decisions about how to fine-tune your LLM application. Alright, let's see how we can use the groups in LangSmith. The main purpose of the applications that we are going to create now is to group multiple LLM runs together under a specific name. This is incredibly useful for organizing and analyzing your experiment with LangChain. And to do that, we are going to use a special context manager called trace as chain underscore group to create a group. And inside this context manager, we can make multiple calls to our LLM chain. And all those chains will be automatically grouped together under the name we specify. Let's see how. We'll say from LangChain.callbacks.manager import trace underscore as chain group. This function is the core part of LangSmith functionality, and it is used to create groups of related LLM runs. Next, we will say with trace as chain group, and here we have to specify the group name. I'm going to say Ataya underscore group underscore name, and here I'm going to say as a group underscore manager. All right, and here I'm going to say pass for the sake of this example. So here, this line, we created a context manager using the imported trace as chain group. And as we said before, the context manager is like, you can say, a Python constructor that creates a temporary environment for code execution. All right. In this case, Ataya underscore group underscore name is the name we give to the group. We can choose any name. All right. And as group manager, assign the context manager functionality to a variable called a group manager. We will use this variable to associate LLM run with this group. And pass here is just a placeholder statement. In real-world application, we have to run the code for our LLM chain within this block. Now let's create our LLM and prompt template and chain. So we'll say from LangChain.chat underscore models import chat open AI, and then from LangChain.chains import LLM chain, and from LangChain.prompts import prompt template. Okay, and before I move on here, I forgot a T. Okay, next we are going to create the LLM object, which is equal to chat open AI temperature, let's say this time 0.7, okay, and then prompt is equal to prompt template, and here we are going to define the input variable underscore variables is equal to question, and the template is equal to what is the answer to question, okay. After that we will create the chain is equal to LLM chain, and LLM is equal to LLM, and prompt is equal to prompt, okay. Now we will use the context manager to group runs. So we'll say with trace as group chain, and here I'm going to pass the group name Ataya underscore group underscore name, okay, as a group manager, and then here we'll have chain.run question is equal to what is your name, and callbacks is equal to a group underscore manager. I'm gonna explain this in a minute. And chain.run, the next question is equal to what is your age. Callbacks is equal to a group underscore manager. And finally chain.run question equal where do you work, okay. Callbacks is equal to group manager. So what we are doing here is that we are grouping similar question together under one group name called Ataya underscore group underscore name using the group manager here, all right. And the callback here is telling LangSmith to write the question and answer in our group. And since they are all run under the similar group, LangSmith knows that they belong together. So let's run our code. And now let's go to LangSmith to see what happened. Now in LangSmith, we can see this group name called Ataya underscore group name. And if we drill down, we can see the 3 LLM calls here. The first one, what's your name, what is your age, where do you work. We can see as well the latency, the token used, and the cost of each call. And also here we can filter based on the group name as well. And all these LLM calls were made under one group called Ataya underscore group name. So that's how you can use LangSmith to track and group your LLM runs for better analysis and insights. In the next part, we will dive deeper onto the LangSmith Client, which is a powerful tool that allows us to interact with LangSmith directly from our code. LangSmith Client is your backstage pass to the platform. It lets you interact with all the features we have seen so far, like listing run, filtering data, or even upload your own dataset. But you do it all directly from your code, like a power user. This opens up a whole world of possibilities for automating your workflow and building a custom tool that perfectly fits your need. To work with LangSmith Client, we have to import the client class from LangSmith. Then we have to initiate that client, and it will read the API key from the environment variable. Let's see how. So here we will say the following: from LangSmith import client, and then we are going to initiate a client here equal client. And now to get the list of project run, we'll say project underscore runs is equal to client dot list underscore runs. And here we have to pass the project name or ID, but let's go with the project name, and I'm going to choose default, the default project that we have. And finally, now we can print the project run underscore run. Let's run the code. As you can see, it does not directly return the list of runs, but it returns a generated object, and we can iterate over it one by one. But before we do that, I'm going to show you how we can add constraint to the run. For example, if you want to get the list of run from yesterday, let's see how we can do that. Here we'll say from date time import date time and time delta. Then we'll say here today underscore runs is equal to client dot list underscore runs, and for project name I'm going to use default as well, default. All right, and for start time it's going to be equal to date time dot now minus time delta days equal 1. All right, and the run underscore type, here we can specify the run type. For example, I'm going to choose LLM, but you can choose agent or whatever you want, depends on your need. And finally we can again here print the today's run. Let's run the code, and as you can see this also return an object generator, and to get the information we have to loop over it. So we will say here for run in today's underscore run and today underscore run. Okay, print run. Okay, let's run the code, and we get the run. As you can see here in the output, we get the name, chat OpenAI, the start time, and the run type as well. All right, so that's how you can use the client to access this type of data for our runs. Sometimes while working with LangChain, we want to do an A/B test, for example, to try out different model. And that's where metadata comes in and allow us to do that. Let's see how. To see how metadata work in LangSmith, we have to create a chain first and then pass that chain a metadata attribute. All right, let's see how. So we'll say from LangChain dot chat underscore models import chat OpenAI, and then from LangChain dot chains import LLM chains. Okay, now we'll create our chat underscore model, which is equal to chat OpenAI. All right, now we will create our chain is equal to LLM chain dot from underscore string, and here LLM is equal to chat underscore model, and template we can say, for example, what is the answer to the following input. All right, our purpose is to learn metadata, so let's not focus on the chain. All right, now when we are making a call to the chain, for example, input here, what is the capital of France? All right, here we can pass the metadata. We pass it as a dictionary. So we'll say here metadata equal source, for example, and let's say internet. Okay, let's run our code, and we get an error because I forgot to add this here. Let's run the code cell again. Now it's working. What is the capital of France? And the answer is the capital of France is Paris. All right, so this is now made a request to the OpenAI, and we can use that metadata that we attach it to the chain to filter that run. And in order to do that, we have first to import the client again, initiate it, and then list the our run again and use the filter. Let's see how. So we'll say here from LangSmith import client, and then client is equal to client, and then runs is equal to list client dot list underscore runs. Okay, and here we'll pass the project name, I made a mistake, list underscore run. Okay, and here project name is equal, let's say default again. All right, and filter, the filter here has a very strange syntax, okay, but it's very specific and it is what it is. So this is how you pass the filter. So you have to say here has, and here we'll say it has what? It has a metadata, okay, and we'll use the escape key. And here in a single quote, I have to be very careful not to have any mistake. We'll pass the source, okay, and as we said at the beginning there, internet. All right, that's it. All right, and now we can print the list of run related to that metadata. List runs. Let's run the code, and I get an error. I knew I made a mistake, so here I have to add another escape key. All right, let's run the code. It's running, and we get empty. You get empty result when the metadata is wrong. Okay, let's check what is the difference here. Yeah, the spelling is different. I made a spelling mistake. Let's run it again, and we get the list of run for that specific metadata. You see here, this is the source is internet, and that's how you can use metadata in LangSmith. Alright, now let's talk about dataset in LangSmith. But first, why do we even want to upload our own dataset to LangSmith? LangSmith is not a platform to store large amount of data. It's for data to test our LLM or prompt against. Datasets are like a test benches for your LLM. Instead of throwing random question at your model, you can use a carefully curated dataset to see how well it performs on specific task or type of input. This allows us to track performance over time, compare different models, and find those errors in the LLM responses. In this final example, we are going to upload a dataset which is now in CSV format. We are going to use the client class from LangSmith again to upload the dataset. Of course, the dataset could be in any other format. This dataset contains 5 questions with answers and explanation, category, and difficulties. And we want this dataset to be evaluated. Let's first upload this dataset to LangSmith and see how we can evaluate it. So we are going to import from LangSmith, import client, and then we are going to initiate the client again. Now we are going to create a variable called dataset, and we are going to say here client.upload underscore CSV. The first variable parameter we have to specify is the location. I have this dataset located under files dataset.csv, okay, in the same directory as this Jupyter notebook. Now the input keys, now we have to specify the input keys. It's going to be the question. Alright, let me just type it correctly, question. And the output keys is going to be the answer. And for name, I'm going to call it first CSV dataset. Alright, description dataset with 5 questions and answers in CSV format. Alright, and finally data type is going to equal to KV. Now let's run the code cell. It uploaded the dataset to LangSmith. Let's go now to LangSmith and see what happened. In the home page of LangSmith now, we can see under dataset and testing that we have one dataset. If we click on it, it's our dataset. First CSV dataset. A dataset with 5 questions and answers. And if we open it, we can see here the input and the output and created date and so on. Now we want to test our model against the dataset, and to do that we will use a built-in functionality from LangSmith where we can import the run eval config class from LangSmith and also import the run on dataset function. We will see how now. So to evaluate our model against the dataset, we have to first create a config for our evaluator. So first here we'll say from LangSmith import client because we need the client to get access to the dataset. And then from LangChain .smith import run evaluate config and run underscore on dataset. These two components are very essential from LangChain. The run evaluate config class is used to configure how LangSmith evaluate our large language model performance on the dataset. Run on dataset function is the core of our evaluation process. It takes our dataset and the LLM or the LangChain and our evaluation configuration and orchestrates the whole evaluation workflow. Let's see how. Then now we have to create an instance of the run evaluate config class to hold our evaluation setting. So we'll say here evaluation underscore config is equal to run eval config and evaluators are equal to QA and then context underscore QA and then COT underscore QA. A QA is a simple question answer evaluator. It will check if the LLM's response matches the ground truth answer in our dataset. So it will compare the response from the LLM to the answer in our dataset. The context underscore QA, this evaluator takes context into account. It considers the surrounding text and document when assessing the LLM response. And the COT underscore QA, this evaluator uses the chain of thought prompting, which encourages the LLM to provide step-by-step reasoning before giving its final answer. Let's run our code cell and make sure everything is working fine. And it's working. Now we will initiate our client. Client is equal to client. LLM is equal to chat OpenAI. And run on dataset. It is designed to streamline the tasks of testing our LLM. The first parameter that we have to pass is the dataset name, which is going to be equal the dataset that we created here, first CSV dataset. Let me copy it so that we don't make any mistake. Alright. Next, we need to pass our large language model object. So we'll say here LLM or chain factory is equal to LLM. Client is equal to client. And evaluation is equal to evaluation config. And project underscore name, let's call it evaluation project. And what is going to happen after we run the code cell now, LangSmith will retrieve the dataset we specified, alright, which is already uploaded in LangSmith. Then it will run the LLM object or the chain that we pass here on the dataset by sending the input and collecting the output. And then it will apply the specific evaluator that we define here to compare the LLM output to the expected answers in our dataset. And finally, it will store the result in LangSmith. Let me scroll up and let me run the code cell now. It's running now, it's evaluating. We have 0 out of 5 completed so far. It's gonna take some time. And it's completed. And it's always better to see the result on LangSmith. So we can click here and check the result. And here we can see the result for the 5 questions. And as we can see, the AI model was able to answer all the 5 questions correctly. And we can dig deeper, and if we click here in the first question, we can see this is the input and this is the output and this is the run. If we click on this one, we can see that this is the input, the question from the human, and this is the AI output. Okay, and this is the reference. We can see that we have also tags, and this is the data set that we use as well. We can say the same for the second question. If we click here, this is our question, and this is the answer from the AI model. And now if we go also to the home page, we see we have 3 projects. And here is our evaluator project. And we can see here the list of all run. And here we can see we have total of 15 run, and this is the cost, and the error rate, we have 0 error rate. And we can filter based on the type of configuration we use, for example, COT, chain of thought. One little warning before we finish this tutorial: evaluation can be quite costly when you evaluate the LLM on a large amount of data. For this example, we only use a CSV file with 5 questions and 5 answers. So hopefully you get a nice idea of what LangSmith is and how well it integrates with LangChain. Alright, there you have it. By this we reached to the end of today's tutorial, and we have just scratched the surface of what LangSmith can do. You have seen now how to unlock a new level of control and visibility over your LLM application. With LangSmith's powerful tool in your arsenal, you are on your way to build more efficient and insightful AI system. If you enjoyed this tutorial and want to learn more about LangSmith and LangChain, be sure to hit the like button, subscribe to my channel, and ring the notification bell. Thank you for watching and happy coding.